Okay, so I'm going to screencast the solutions to the test. That way, I mean, you guys will understand it if you want to watch it later. So consider the function. So right away, do we see what's going to be happening to it? What does this plus 4 do? So this is going to shift it up. So it's going to be a vertical shift of 4. And it's going to go up, vertical shift up by 4. And Talia's right. This is where the asymptote normally is at y equals 0. All right, so the asymptote normally is at the x-axis. But since I'm shifting everything up 4, I have to add 4. So what is y equals 0 plus 4? What is that line going to be? Yeah, y equals 4. Okay, do we have a horizontal shift here? Do we have a horizontal shift? No, we don't. We don't have a horizontal shift. The horizontal shift would be right here. Right, it'd be plus a number. I don't know, there's not a number here. So there's no horizontal shift. Is this growth or decay? How do you know?
It's growth.
Good, it's decay because the base is less than 1. All right, so think about what the domain and the range would be. Think about what the domain and range would be. Yep, the domain is from negative infinity to positive infinity. Where is this not? Negative infinity to positive infinity, right? So we know it's going to be all real numbers, but I want you to get in a habit of saying negative infinity to infinity, mostly for, you know, sophomores and juniors, because that's what you're going to have to use next year. So I want you to write negative infinity to infinity. So I'm telling you what I want you to write. Okay. What about the range? Do we know what the range will be, or should we graph it first? Y is greater than 4. And if we didn't see that right away, because we don't touch the asymptote. The asymptote is the freeway median. We get close to it, we don't touch it, and we don't cross it. So it's going to be y is greater than 4. So I'm drawing my dotted line. That's the asymptote. That's y is equal to 4. Well, technically it would be 4 to infinity. Is what it would be. You like ran out yesterday. I was trying to give people these.
Oh.
What's wrong? No. No, because it's, well, let's graph and let's see on which side of the asymptote it will be. The shifts? So the vertical shift is going to be what's being, if I have a number being added to it here versus if it's in the exponent, it's horizontal. If it's not in the exponent, it'll be vertical. Yeah. Okay. So let's graph it. Let's see what we have. This is a way to write 4 to infinity. All of our y values are going to be larger than 4, so that's the way you would write it. So here's our x. What number should I pick for my x to plug in? Should I pick like 10? No, Miles, what would be a good one?
Like numbers around 4.
Numbers around 4?
Yeah.
Well, let's look. So it depends on our exponent. If I had an exponent that was like 1/3 to the x plus 4.
So you just do like negative 1, 0, 1, 2.
Exactly. So I'm going to pick like negative 1, negative 1, 0, 1. Let's see what values this gives us. I'm picking numbers where the exponent will be small. Not necessarily small numbers, I want the exponent to be small. So if my exponent was, let's see, okay, 1/3. If my exponent was like x plus 4, what number could I plug in that would make my exponent 0? Negative 4, right. So all my numbers would be clustered around negative 4. Here, I just have to the x. So all my numbers are going to be clustered around 0. That's a hint. That should hopefully help. All right, plug in the numbers. All right, so plug it in. See what values we get. This is a test review day. I shouldn't have to walk you through everything. Try it out. I want you to know how to do this. Plug in these three numbers, see what values we get. Okay. So I have 1/3 -1 plus 4. So that's 3 to the first over 1 plus 4. So it's 7. Good. And then if I put in 1/3 to the 0 plus 4, that's going to be 1 plus 4 because 1/3 to the 0 is 1. So that's 5. Let's put in 1. So let's see, 1/3 to the first plus 4. That's literally just going to be 4 and 1/3. All right, so let's try, so we centered around 0, we tried -1, we tried 1. Let's go to like -2 and 2. -2 and 2. What? 1/3 to the -2 plus 4 is going to be 3 squared over 1 plus 4, because getting rid of the negative in the exponent, I flip it. What? Yeah, because I centered around 0 and then I'm like working my way out on each side. So that's 9 plus 4, which is 13. That's off my graph. 1/3 squared plus 4. So that's 1/9 plus 4. So it's going to be 4 and 1/9. By the way. All right. Go ahead, plot these points. So -1, 7 is right here. Uh, 0, 5. 1, 4 and 1/3. Okay, so it's just a little bit above 4. This pen is so stupid. Okay. We have -2, 13. Okay, so that's like off my chart. It's like crazy. It's up here somewhere. And then 2, 4 and 1/9. So that's also super close to the asymptote. So that's enough points. We can plot this just fine. So it looks like that. Awesome. So I see all my y values are above 4. All my y values are above 4, so my range was correct. Do we need more time before we go on? What? So I probably should have drawn this side better. Okay. So it comes down. Does not touch the asymptote. Does not touch it. Gets really close. Okay. Cool. Let's go on to the next one. All right. So now we have an opportunity to get participation points. Because you can like tell me what to write. I'll do it, walk us through a problem. So for example, this number 2, like literally every single step. Tell me what to do and why it's that way. Yes. You can do it? Okay.
So you equal it to y. And then you do 8y.
8 to the y.
To the y and it equals 1/2.
Because it's 8 to the y power, not necessarily 8 times y. Good. Okay. Now what?
We can make the base look the same.
Mm-hmm.
So then, we need to do the.
What am I going to choose as my base? Okay. So 8 to what power? I'm sorry, 2 to what power is 8? And then 2 to what power is 1/2? -1?
Then we do 3y equals -1. We divide 3.
Good. On both sides. We find y is equal to -1/3. Awesome. Questions over that one?
Yeah, what?
Okay. I'll pause a second.
What lesson is this?
2? Lesson 2? I think so.
I'm confused.
I think it's 7.2. Yeah.
This is Ryan. Are you in that water? Is that car in the bathroom?
No.
Really?
You're leaving the room, you're missing instruction. Let's go to the next one. 5 times ln of e squared. Any takers?
I'm not really good with
Yeah,
that.
that's right.
So I don't
Let's try. So
actually just
let's
follow
use the power property of logarithms.
What are we solving?
I'm trying to simplify. So you bring the 2 out front. So 2 times 5 times ln of e. What's ln of e equal to? Yeah, that whole thing's equal to 1. So what's 2 times 5? 10. That's it. -1/3. Yeah, I was just gonna write the answers over there. Okay. Alright, let's make sure our phones are put away. We're not texting. Totally put away in our bags, not on your desk. 10.
So would I just say 10 or do I
That's
say
it, 10. 10's the answer. And the reason is because ln of e is the same thing as saying log base e of e. And if I would try to solve log base e of e, alright, I like have my y, e to the y is equal to e to the first. So I see like, oh, okay. Evaluating log base e of e literally gives you 1. So this whole thing goes to 1. 2 times 5 times 1 is 10. Alright? Alright. Go ahead, Miles.
Okay, so 25 doesn't go into 125, so you could break it down smaller. So it would be, you have to break it down to 5. So on the left, it'd be 5 squared, parentheses 3x plus 4 equals 5 to the 3rd power, and then plus, yeah.
Okay.
And then you multiply it out. So on the left hand side, it would be 5 to 6x plus 8, and then it would be equals 5 to the 3x plus 6. And then you would rewrite the problem with 6x plus 8 equals 3x plus 6. Then you'd subtract.
Did you? Yeah.
Subtract 3x.
Let's make sure. Okay. Subtract 3x on both sides. You have it right, Tamara?
3x plus 8 equals 6.
Okay, so let's pause for a second. How did we go from this line to that one? How did I get rid of the base 5? Not necessarily cancel out, but because they have the same base, I can set the exponents equal. So I'm not like canceling it out, I'm just setting the bases equal to each other. So cool.
And then you're
Close.
gonna subtract 8. You're gonna be 3x equals -2, and then you're gonna divide the 3 to the -2. So it will be x equals -2/3.
Good. X equals -2/3. Great. Excellent. Good job. All right, number 5. I'll let you look at it. Any takers? It is possible to get over 100% on participation. Help your grade. All right, Miles, you're gonna take this one.
Yeah.
Awesome.
It would be 64 to the 2/3 power equals 10.
Cool.
And then
So you have 2 options. You could evaluate it with a calculator, find the answer, or what I would want you to do is like, okay, let me rewrite this as the cube root of 64 squared. So what times itself 3 times is 64? Blank? 4. 4 times 4 is 16 times 4 is 64. So this middle part evaluates to 4, and then 4 squared, 16. Okay, so I think this practice test is like 20 questions long. I'm shooting for like 14 to 15 questions. So on the actual test, just to FYI. Also, if you are going to go, no, we already talked about this yesterday. Okay, so everyone will be here in class tomorrow. The perm reading doesn't really affect you in this class. If you want to take your extension, email me by tonight. If you have extended time, we're going to have you take the extended time in Miss Vandel's room immediately after class tomorrow. Yep.
what's next? The next chapter test on?
Chapter 8.
Yeah.
I can give you one. It's fine. I think I have one extra. Maybe there's 2 extra. I know there are a couple people that like ran out of here fast yesterday, so before I pass them out. All right. I think it's rational functions. I haven't looked very closely at it. Been mostly focused on this chapter. So just look in your textbook, and then you'll see. You can decide if you want to use it for this chapter test or the next one, which one would be better for you. All right, let's try 6. Any takers want to try 6? All right, go ahead. Not necessarily cancel out, but because they have the same base, we'll set the inside equal to each other. Set the inside equal to each other. Good. So, like, I have to make sure I don't run into an extraneous solution, but this is fine. If I put in 7 and for x, on the left side, I would get 19 log base 4 of 19 after I'd plug it in. Right, on the right side, I would get log base 4 19. Okay.
Why didn't you just get rid of the log because it had the same base?
Because they have the same base. It's kind of like saying, you know, like a teeter-totter or a seesaw? Like, for it to be perfectly balanced, then, like, whoever's on the right side, literally their clone has to be on the left because it's the same weight. Here, I have this equal sign in between the left and right side. And if I'm taking log base 4 of this number, it has to equal log base 4 of, like, the number that's on the other side. So because they have the same base, I can set what's inside equal to each other because they have to be equal. So it's not necessarily like canceling out, it's setting the inside equal to each other because I know since they have the same base, they'll have the same exponent and result. Okay, so that was x equals 7. Let's try number 7. Anyone want to try this one?
I just have a question on it.
Yes.
Okay, so if there's two logs on like the right side of the equation, can you cross them both out?
Nope, you have to, in order to set it equal like we've been doing, you have to have only one log on each side. So first we have to get like the logs on the right side together. How can I combine these two logarithms? Well, first, oh my gosh, I have these coefficients. What do I do with them? I bring them up to be exponents. So I have, oh my gosh, let me zoom in. So I have log base 5 of n is going to equal log base 5 of 64 to the 1/3 plus log base 5 of 49 to the 1/2 power. Do I know what 64 to the 3rd power is? What is the cube root of 64? What times itself 3 times is 64? Yeah, so this is 4. What about square root of 49? Okay, so I'm just going to rewrite knowing that we evaluated those. Okay, so, I want to use the little trick that we learned where if they have the same log base, I can, on either side of the equal sign, I can like set the insides equal. The issue I have is I have 2 logs on my right side. How can I combine these? How can I condense these? If I'm adding 2 logs together, the product property of logarithms, 7.4. So if I am adding 2 logs together, I can rewrite this as the multiplication of what's on the inside. So this is the product property of logarithms. So that means n is equal to 4 times 7, which is 28. Because what I did was since I had the same log base, I set the insides equal to each other. Because I have the same base on both sides, I can set the insides equal to each other. Yep. Yeah, that's it. All right, number 8. Well, let's see. Yeah, let's do this one. Any takers? This is your chance to get participation points. So hint, put each side in the same like base. 16 and 1/4, can I rewrite it in terms of, yeah? Because 16 has an exponent. Yeah. What if I rewrote this as, oops, 4 squared and minus 7? Because 16 is equal to 4 squared.
Yeah, and then it would be 4 to the negative 1st power.
Yeah.
And then you multiply that out, so it would be 4, and then it would be m to the, that's 2m minus 14 equals.
Okay.
So 2m minus 14 equals negative 1. You add the 14, so it would be 2m equals negative 1. Oh, yeah. Oh, yeah, 2m equals 13, and we divide by 2. So that's
Awesome, exactly. So it's just like a previous problem we did. Rewrite both sides having the same base. Set the exponents equal to each other. Because I have a base of 4 on both sides, I can set the exponents equal to each other, and then you just solve for the variable. So how do you know what to use when? Is that the problem? We don't know what to use?
Yeah.
Okay, so if you see multiple logarithms like this next problem, you're probably going to want to combine them. Multiple logs, you need to combine them. If you see like a single log, you're solving for the variable. If you see numbers on both sides with exponents, you're going to have to be solving for the exponent. It's like 4 different things I would ask you to do. So for instance, this one, I am subtracting 2 logs. So how can I combine them to get it into a single logarithm? You have an idea? Okay. So you said, so we combine them using the quotient property? Yeah? No? Oop. Quotient property of logarithms. So what that means is it's going to be the left one divided by the right one equals 1. Oop, log base 4. Okay, now what? Yep, we go ahead and we solve it. 4 to the first power is going to equal 2n plus 2 over n minus 2. So I can multiply both sides by n minus 2. Multiply this side by n minus 2. So 4n minus 8 is equal to 2n plus 2.
And
Subtract 2n from both sides, add 8. Let's see, so add 8, subtract 2n, divide by 2, and I get n equals 5.
What are the arrows?
So that's how you evaluate that's how you change a logarithm to be an exponential.
How do I know what to do?
So log base result equals exponent. So, and we change it, so exponential forms, this is something else. Exponential form is base to the exponent equals result. So I have base to the exponent equals result. So the base to whatever it's equal, to whatever like is on the other side equal sign, right, that'll be the exponent equals result. All right, we have questions over this one, or are we good to keep going? Do I need to wait? Am I okay? Okay. So let's go to, some of these are, yeah. I guess we just keep going. That's fine. Like 10 more minutes. Yeah. Okay, how can I combine these? Like, so see there's more than one log on a side. I'm gonna have to use a property of logarithms. Here, how do I know which property to use? Because it's subtraction, I'm gonna use the division. Good. So log base 7 of the left one over the right one. So notice I only wrote log once. I went from 2 logs to 1 log. All right, and this is equal to, well, I'm going to rewrite the right side, log base 7 of 10. Now what?
Did you divide both sides by log base 7 of 10?
Not divide, but since they both are log base 7, I'll just set the inside equal to each other. Right.
100 y plus 5 equals 10.
100 over y plus 5 is equal to 10. So if I multiply both sides, multiply both sides by y plus 5, that will cancel on the left side, and I have y plus 5 over here. 100 equals 10y plus 50. So distribute the 10 out. Minus 50 on both sides. Divide by 10, y is 5. Jack, you okay? Alright. Write this down. Alright. Let's try number 11. So you all have your calculator for the whole time, so that's fine. Number 11, how would I go about solving this? Sorry, I'll zoom out a little bit. Subtract 2 from both sides. Then what? Then divide by 5, so subtract 2.
Then we do both sides by ln.
Yep. Take ln of both sides. Because I had that coefficient of 5 right here I wanted to get rid of.
So then you would eliminate and it'd be negative 3x equals 1 ln.
Negative 3x equals ln of 1. So x is equal to ln of 1 over negative 3. So we took log of both sides. Because what I'm trying to solve for is in the exponent, right? That x is in the exponent. I take natural log of both sides, and that gets rid of e, the base e. And the reason that happens, so I'll show you over here as a little aside. Power property, bring it in front. What? Yeah, ln of 1 is 0. So that's equal to 0. Let's see, that's equal to 1. So it goes away. Alright, cool. Let's go to number 12. Think about how we would solve number 12. What would be the first thing I could do? Close. So what I'm trying to solve for is inside what I'm taking the log of. So what I can do is have each side be my exponent. So it's not like raise to each side to e, but literally put e to the power of each side. So I have e to the ln of x plus 5 is going to equal e to the 7. Guess what happens to this ln and e on the left side? They eliminate, so I have x plus 5 is equal to e to the 7th. How do I solve for x? E to the 7 minus 5. Yeah. Well, we're supposed to round to nearest 10,000, so in your calculator you would. So if you put that in, what is it equal to? Alright, friendly reminder, make sure you have your calculator charged with you and ready tomorrow, because you won't be able to share.
1091.63.
How do you put that in?
So to the nearest 10,000. So let's see. I'll show you how to plug it in. E to the 7 minus 5. All right. Okay, so I have, there's this little e to the x button. Oops, I don't know why I pushed it so many times. So e to the 7. Push the arrow key over by 1, that way I'm out of the exponent, and then I minus 5.
I just got it. Thank you.
Okay. Alright. So cool. So this is literally the exact answers. So like, that's it. There's no more decimal places needed. Alright, number 13. 2 to the x minus 1 equals 17. So the reason we were doing ln before is because the base was e. Because remember, ln is literally log base e. So you're doing log base of whatever the base was. So I'm going to do log base 2 of both sides. Log base 2 of 17. So earlier we chose ln, the natural log, because natural log is log base e. Because I had a base that was e. So here I chose, like, here I chose to do ln on both sides because my base was e. ln is literally log base e. So I'm doing log base of whatever the original base was. Here, our base was 2, so I'm doing log base 2. Yeah. So I'll, yeah, x minus 1 times log base 2 of 2, so that goes to 1. Equals log base 2 of 17. So that's equal to 1, because I'm trying to show you guys all the steps. So I have x minus 1 equals log base 2 of 17. So x is equal to log base 2 of 17 plus 1. So cool thing is your calculator can solve this. It can. It can do it. I'll show you how. So I push control 10 to the x, because that gives me log. And notice I'm doing a base 2, so I have to put 2 here. And then go up 17, and then I'm minusing 1. Minus 1, 3.0875.
No, you're adding.
Adding 1? Dang it. Okay. Plus 1. 5.0875. Because we're rounding to the nearest 10,000. Right. So we are out of time for class, but I'll upload the solutions today. Alright, so here's the stuff we didn't get to in class. So we're going to use log base 5 of 2 and log base 5 of 3 to approximate the value of each expression. Okay, so if I could rewrite this as a sum of logs. So first, a sum of logs, what I mean by that is if I could figure this out as a product, so maybe log base 2 times 9, that's 18, but I also could do log base, yeah, let's just do this, 2 times 9. Okay, so since this is a product, I can rewrite this as log base 5 of 2 plus log base 5 of, well, 9 is just 3 squared. Alright, 9 is 3 squared. And using properties of logs, I can move this to the front, so now I have log base 5 of 2 plus 2 times log base 5 of 3. Log base 5 of 2 is 0.4307 plus 2 times log base 5 of 3 is 0.6826. So go ahead, put this in your calculator, and let's see what we get. 1.7959. Perfect. Let's try the next one. This is division, so I could rewrite this as log base 5 of 9 minus log base 5 of 4. Each of these I can write as, let's see, log base 5 of 3 squared minus log base 5 of 2 squared. Bring the 2's out front. With the power property, 2 times log base 5 of 3 minus 2 times log base 5 of 2. Alright, so that's going to be 2 times 0.6826 minus 2 times 0.4307. Put this in your calculator and you will find the answer is 0.5038. Awesome. Write the equation in exponential form. So you go from the base to the exponent. This is 3 to the 5th equals x. And that's it. That's an exponential form. Write the equation in log form. So remember log. So remember it's log base result equals exponent. So log 464 equals x. It's not asking to solve, just write in log form. Alright, suppose you deposit $1,000 in a bank account. So this is going to be your principal. It's how much you start with. An account that pays 7.2 annual interest, so my rate is 0.072. Compounded continuously. Okay, so this means I'm going to use the equation with E. Find the balance after 5 years. So A equals P times E to the RT. This 5 years is my time. So A equals 1,000 times E to the 0.072 times 5. Put this in your calculator so I can show you how to do this. So I have 1,000 times E to the 0.072 times 5. So you can slow that down if you want to see which keys I pushed. It looks just like on the right side. Oops, I don't think my bad. 1,000. Then I push the E to the X key. Oh, I see. I just put E on my keyboard instead of pushing the key on the computer. 0.072 times 5. There. So I get that my balance would be $1,433.33. Awesome. Okay. In 5 months, half of a 22-gram sample of radioactive element remains. Find the constant K for this element for T hours. Okay, so we want it in hours. Ooh, tricky. After some consideration, I decided I would not do this to you because that's horrid. I'm going to make this be hours. That way I have the same time. Okay. Same time unit. Don't have to make you convert between because that would be mean. Okay. So, the way I'm going to do this is y equals a. Oh my god. Y equals a times e to the kt. Right, so I know that I'm ending with half the amount I started with. Times e to the k times 5. As I said, it was 5 hours. That goes away. I have 1/2 is equal to e to the k times 5. Take ln of both sides. Ln of 1/2 is equal to ln of e to the 5k. So I have ln of 1/2 is equal to 5k. Divide by 5 on both sides. K is equal to ln of 1/2 divided by 5. So this means K is equal to negative 0.1386. Oh my gosh, I swear I'm gonna get a new pen. Okay, negative 0.1386. That's what I was asking for, was K, and we rounded to the nearest 10,000th. Then write the equation modeling its exponential decay. Awesome. So the way we would write this is y is equal to a, because that depends how much we're starting with, times e to the negative 0.1386t. Actually, it did say we're starting with 22 grams, so I'll put 22 here because that's how much we're starting with. And this will give you how many grams you'll have after t hours. All right, last one. Rent prices in your building have increased 3% annually since 2010. Suppose the rent was $17.50 in 2010, and the growth continues. What will the rent be in 2020? All right, we're starting with $17.50. Our rate is 3%. So that's 0.03. Our time, 2010 to 2020, that's a time difference of 10 years. Y equals, and it's only once a year. Okay, so once a year, so n equals 1, so I can have a, y, well, I could use a, be my principal, p, a equals p times 1 plus r over n, all to the nt. If I plug in n for 1, I have a equals p times 1 plus r to the t. So if I plug in 1 for n, that's what it goes to. So a is equal to 1750 times 1 plus 0.03, all to the 10 power. So we get $2,351.85 would be the total. Cool, and that's it for the practice test.